I am Sultan Ziad, and this is my Physics 1 Lab 1 on constant velocity. The purpose of this lab is to compare the observed motion of an object moving at a constant speed to the predicted motion of that object based on a computational model, or observed versus predicted for short. The models and principles needed for this lab: tracker software was used, GlowScript coding was used, and Google Sheets was used for data entering and analysis. And also Newton's first law and Newton's second law are also important here. Newton's first law being an object at rest remains at rest, or if in motion remains in motion at a constant velocity unless acted on by a net external force. And then Newton's second law, force equals mass times acceleration. And then I've also included the position update formula and the velocity update formula as well, because those were also important to complete this lab. This is a preview of the result, and I'll explain how we got here, but it just shows you a graph of the model versus the experiment position, and so I'll go into how I came to that. For systems and surroundings, the system was the can rolling across the floor, and then the surroundings were the surroundings affecting the can's movement, and in this case that's just the floor. For initial conditions, some pre-coding calculations were needed: the initial position, the average velocity, and the time of the last observation. To get the initial position, that was found by looking at the first point on the tracker data. To get the average velocity, that was found by taking the change in position between the first 2 points over the change in time between the first 2 points. And then for time of last observation, that was just found by looking at the data. For the procedure, first, a video of the can rolling across the floor was taken, and then that video was uploaded to the tracker software to get the analysis that you see here on the right. Then the coding aspect of the procedure. So we had the sample code, and then I took the sample code and updated some of the values to match my particular experiment, my particular data. And so I've sort of boxed around in red where those changes were made, and you can kind of see how I made that specific to my data and my can rolling across the floor. And then after that code is edited, then I ran the model, and you can see the position versus time graph and model here. And so then you can kind of see the difference between the experiment position and the model position again, like I showed earlier. They're slightly different, and this is most likely due to friction or other things, other forces affecting the can rolling across the floor that aren't accounted for in the model. And so it's also important to think about what would happen if this was slightly different. If the y-axis were flipped, what would happen? And in that case, the object would be moving in the opposite direction, bottom left from the bottom left to the top right instead. And if the x-axis were flipped, it would move from the top right to the bottom left. And then some possible errors: I already mentioned friction, but also airflow in the surrounding environment, and maybe the floor is uneven, or there are uneven parts of the can surface as well that may be affecting things.